Okay, to write something in scientific notation means you need to end up with a number between 1 and 10 multiplied by 10 to some power. And that power is going to just be an integer. So no fractions, no decimals, though it can be negative. So 77,730. So what I end up with needs to be equivalent to that, but just written in that form. So I need to take the decimal point and move it either left or right. Well, to get a number between 1 and 10, I got to go left. That's not far enough, nor is that, but that is putting us at 7.7730, and you don't need the zero, times 10 to the, let's see, how many bumps are there? 1, 2, 3, 4. So times 10 to the fourth. Okay. Now, at some point, we have to ask ourselves, well, how do I know if the 4 is positive or negative? Because that's coming up really soon. Well, you just remember this. I started off with a really big number, 77,000, and I made it smaller. And to compensate for making it smaller, I'm going to do a positive exponent, because that'll, if I multiply all this out again, that positive exponent will fluff it back up to 77,000. Okay. So on something like this one, again, we're going to convert it into scientific notation, but this time it's, instead of bigger than a number between 1 and 10, it's smaller. So I would need to take the exponent and move it to the left. 1, 2, 3, 4, 5, 6 decimal places, 6 bumps. So I end up with 7.22 times 10 to the what? Well, there's 6 bumps, but notice we started with a number that was really small and we made it really big. And what we end up with at the end is supposed to be equivalent. So to compensate for making it bigger, the exponent's going to be negative, because that'll shrink it back down if we multiply all this out. All right. Now on this one, all they're saying is take the number they give you and make it scientific notation, except they're going to give you a story, which makes it more interesting. But in science, that's one of the main places where you see scientific notation, because you know in science sometimes numbers get really big, well, really long to write out, so we write it in scientific notation. Okay, so the first one, it says write this number is already in scientific notation, so let's write it in decimal notation. So 2.68 times 10 to the negative 4. So the exponent is negative. That means, hey, this number is actually really small. Let's make it smaller. So we take the 2.68 and we move the decimal point in the get smaller direction. 1, 2, 3, 4 places. So the exponent ends up there, and empty slots get zeros. So it's 0.000268. That is the final answer. Okay. Now on part B, we are given again a number that needs to be converted to scientific notation. So I'll take the decimal point, move it to the left 5 places. So I end up with a number between 1 and 10. And the 5 will be positive because I had a big number, made it smaller, and to compensate for that, I have a positive exponent that will fluff it back up to full size if I were to multiply this all out again. And be assured, the expression fluff it out is definitely the technical term. I'm just going to do part A because we haven't done a lot of that. So on this guy, write it in standard notation. So the exponent is positive. That means, hey, this number is actually a lot bigger than it looks. So the exponent goes 3 decimal places in the bigger direction. And, oh, whoops, that's not a 0. I'm just circling up the decimal point. And then that empty slot gets a 0, and it's 2,390. Now on this one, we're supposed to multiply them out and make sure the answer is still in scientific notation. So you, anyway, so 9.8 times 4. I got a great idea. How about we go to the calculator? That sounds just super cool. 9.8 times 4 will be 39.2. Right. So, oops, I got to turn that back on. So 39.2. And then using exponent rules, we say, hey, the bases of the exponents are the same, and we're multiplying, so add the exponents. 3 plus -9 is -6. All right, cool. But the answer is not in scientific notation because this number is not between 1 and 10. So I got to move the decimal point to the left one place, so I end up with a number between 1 and 10. So I get 3.92. Now I moved the decimal point one place. So I'm going to either add or subtract 1 for that one place to the exponent. The question is, do I add or subtract? Well, I had 39.2. I made that number smaller. To compensate for making it smaller, the exponent is going to be positive to fluff it back up to full size when the time comes. So we get that right there. So get going on your homework, go forth and fluff it up. Now we do the same thing, except it's division. So we've got 4.9 divided by 7 to kick things off. So let's do that. And we get 0.7. How wonderful is that? And then we've got these guys with division. The bases are the same, so I can subtract the exponents. And -8 minus 9 is -17. Okay, but my answer is not in scientific notation because 0.7 is not between 1 and 10. So I have to take that decimal point and move it, in this case, to the right, so that I end up with a number between 1 and 10. So that'll give me 7 times 10 to the -17th. And we went one decimal place. And we took 0.7, made it bigger. To compensate for that, the exponent's going to be minus, because that'll shrink it back down to normal size, to the original size it was. So then I get 7 times 10 to the -18. And of course, on all of these, you can plug the original in on the main screen, plug in the final, see if you get the same answer. If you don't, well, then there's a problem.